So now we're going on with sensors class, book review, chapter 10. We're going to talk about mechanical pressure instruments. There are a lot of these out there, and understanding how they work basically is important for us, but they're really not the core set of important things that we're learning in this course. So we're going to briefly touch on some of these, and I'm going to give you some brief descriptions of how they should work that might help your kind of understanding as you read through this. But for the most part, we're going to fly through this section. But there are a ton of these out there, so I think they're worth learning. Number one, you've got measurement systems called manometers. Manometers, I think I pronounce them manometers. So the most typical type of manometer is a U-tube manometer. Basically, let's go look at this illustration here on page 105. It's a tube, and it shows you one of these guys here with one tubing end hooked to atmosphere, so it's open atmosphere, and the other tubing end hooked up to whatever you're measuring, whatever pressure you're measuring, right? That's the way it's labeled here. In this case, we know we're hooked to a vacuum. Why do I know I'm hooked to a vacuum? Because look down here in manometer. You'll see that one leg of the fluid has been sucked up higher than the other leg. In this case, they're saying it's 3 inches. So that tells me that that 3 inches of difference has indicated it's been sucked up onto the measuring side. Tells me I've got a slight vacuum on the measuring side compared to atmosphere, right? Because it sucked up some of that liquid. And if there were pressure on this, then it would be pushed the other way. You'd see that liquid be pushed down and depressed some. And that difference between the high leg and the low leg of a manometer is the reading. So they give you little examples here of, leg same means, it's equal pressure to atmosphere. Legs different this way, you've got a negative reading or a vacuum. Legs different this way, you've got a positive reading or a pressure. And that's how a manometer works. The only thing you have to do is determine, based on the weight of the fluid, right, how much pressure you're getting. And it doesn't really matter how big around the manometer can be, because the pressure that a fluid provides is equal to a simple function times the height of that fluid. A lot of these manometers are going to have readings on them. They're designed for a certain fluid that's already in them, and it'll tell you the PSI or vacuum reading right on the manometer. But if it doesn't, you can run a slight calculation based on the weight of the fluid to determine the pressure or the vacuum. And it's entirely based on the height, not based on the diameter, but it is based on the liquid too. Now, a lot of these aren't going to be water, because water will evaporate out to atmosphere eventually. So they're going to put a fluid in there that won't evaporate quite so easily. And so the specific gravity of the fluid counts. The specific gravity is just the weight of the fluid compared to water. Like water has a specific gravity of 1, whereas something slightly heavier than water is going to have a bigger number. And there's a few different types of manometers. You've got the inclined tube manometer, which takes that range of measurement and spreads it across a smaller distance and gives you more increments. It's a more accurate way of looking at it. You've got a dial gauge manometer that uses a little pointer and a float to give you a dial indication. You've got well type manometers that uses like a big bucket of liquid, so that way you can go up and down a very tall tube and have a big reserve tank available with an essential very, very small 0-point change. So these are all different kinds of manometers. They all have different slight configurations that give you different advantages. All right, and I'm not going to read through all of them. These are basic devices that you occasionally see, but they tend to be old school. You tend to see them in old school manufacturing facilities, which we still have plenty of them. But more and more, everybody is switching to electrical devices. All right, so talk about a barometer. A barometer is basically just a column of some sort of liquid, like water or sometimes mercury. And as the external pressure on the surface of that liquid or mercury presses down more or less, then that column goes up and down. With a vacuum at the very top of that column, it allows that you're always comparing the external atmosphere to a vacuum. And as we said before, this is a great way of measuring your atmospheric pressure in reference to a vacuum, which you might need to measure if you have a storm front coming in. So what do we say that generic sea level atmospheric pressure should be? If you remember, 14.7. If you can memorize any number, 14.7 is a useful one to remember. Diaphragm mechanical sensors. Let's talk about mechanical sensors. And this is where you get into more of our sweet spot. Many of the sensors we're currently using on our inexpensive compressors are going to be mechanical sensors. And they are often diaphragm sensors or Bourdon tube sensors. They often look like this right here, this dial right here. They show PSI or PSIG, and they show a specific range of pressures. This is only up to 10 PSI, so this is not useful for any of our pneumatic applications where we want at least 80 or 100 PSI input for many of our applications. But this is what we tend to see in more sensitive, low pressure applications is diaphragm gauges. And what they're doing is measuring between the connection to this sensor and the outside world around this sensor, comparing those pressure differences based on the flex of a diaphragm, which is a little round circle of rubber or some sort of Viton or some sort of high-tech rubber. And if that thing flexes a little bit, it's got a tiny little gauge that pushes up against it and causes that to torque, and then it turns the lever arm on the dial itself. And I'm not going to go into how that mechanical stuff works. You can tear one of these apart if you want. But suffice to say, the more that little diaphragm flexes, the more that little lever turns. These can be pretty accurate. They can be pretty accurate within maybe a half PSI. But frankly, they're not ideal because a little moisture gets in there, gets too cold, gets too hot. That flex changes slightly. So it's really not ideal in multiple type applications. Capsule gauges are similar, but instead of having a simple diaphragm, one disc of rubber, now you've got this whole capsule created by layers or stacks, like a rubber balloon that spreads across multiple lobes. So for a tiny bit of pressure change, you get a much bigger change in movement or actuation of the gauge. So it tends to be more accurate, but it's a lot more complicated and a lot more expensive. Pressure springs use a hollow tube or a Bourdon tube. See, it wraps around the outside of your gauge, and as that tube, like a balloon, fills up, it tends to want to straighten. And then as that tube straightens, it has a little mechanical dial change. So it changes a little dial and then adjusts the measurement. These, in my opinion, are the most common pressure gauges I've seen in general use. You see them a lot everywhere. I use one when I'm measuring my tire pressure. Bellows is just a slightly different approach to that expanding tube. As the bellow expands, it causes a little gear to turn based on a rack and pinion going up and down. I shouldn't say ratchet, it's a rack and pinion going up and down. So then that rack and pinion then turns that gear, and the gear turns the dial. So these are all different methods mechanically of measuring pressure. Honestly, you guys are probably never going to tear one of these suckers apart. What I will say to you, which is very, very important, is know what these terms mean. So when you read about them, make sure that you read the specification sheets on each one of these kinds of gauges before you implement them. Make sure that they can handle the temperature range, the pressures, and the conditions in which you're going to be installing them. They obviously aren't all the same. They all have slight variations in price and what they can do and their accuracy and the conditions you want to put them in: temperature, pressure, different kinds of potential risks in terms of harmful caustic materials or acidic materials. So you want to read through the specs on all of these.